Where are we headed now? Well, let's talk about subject indexing. So again, we're back to this term indexing, this mechanism by which we're going to be aiding people to find their information faster. We're going to be creating an index of sorts. We're going to be doing it based upon subjects. Okay, so again, this is the selection of words. So let's talk about let's look at this, how to use the subject catalog. I already went through this, but let me write it down on the board here. So we've got a search user who comes into the library. We have a librarian who's employed to do this. By the way, just keep in mind, librarians require large amounts of education. Librarians, the norm is you don't get that job until you have a master's degree. Anyways, so user, librarian. The user comes in again. The user has an information need. Then what do? Well, you think of words that might refer to books that could help you, or that could satisfy your info need. Now, one of the problems I'll just say right here is sometimes you have an information need, but you don't know the words. You have what Nick Belkin might call an anomalous state of knowledge. So you are stuck now. How are you going to come up with the right words if you don't even know those words? I mean, even think about it, like medical issues. There's an entire vocabulary that doctors know that most of us have no clue about. We know our child is having trouble breathing, but we don't know to go, oh, that's croup. I want to investigate croup on the web. You don't know. You got words for like symptoms and stuff. If you had the right word, it would make your life a lot easier. So you've got that problem right now, right? You can see that that's going to be an issue. Okay. Then, again, you look up the word or this phrase that you've come up with in the subject catalog. Subject catalog. There will be lots of books with the same subject. So like woodworking. The library doesn't just have one book on woodworking. There's going to be a whole bunch of them. And you have to flip through every card on woodworking and decide whether or not you're going to click on it, so to speak, whether you're going to bother to write down its column number and go to it. For that word that you came up with, which is basically your query into the information retrieval system, the card catalog, the results returned is the set of books that matched that subject index term. All of those books have been given a representation in the system of that word woodworking. Okay? Anyway, so you're going to look up the word and the phrase in the subject catalog, and if it's good, you're going to go to the book. You're going to write it down, everything that I said. Now, that's one thing. Now, what's the librarian's job in all of this? Well, the librarian isn't there finding the book for you, but first of all, the first thing they do is they decide to buy the book. The whole world of acquisitions, what is the right books to fill a library with is a difficult issue in and of itself. But nevertheless, they had to buy the book. And once they bought the book, they have to index it. So they look at the book They open it up, they read through it briefly, and decide on the key subjects or index phrases, whatever they might choose more than one word for that book. All right. And then for each subject that they decide, they create a subject card. All right. This leads us to a really, really big problem. Your brain is not the librarian's brain. That's an entire book. Maybe they are not woodworking experts. Maybe they're not medical experts. Maybe they actually know nothing about what the book is really about. But their job is to pick the words that will best represent that book in their information retrieval system, their card catalog. The user of this system has to think of their need, think of words that they think will lead them to the items that will satisfy them. Okay? Who is to say that these words are going to be these words? Oh my goodness gracious. Because if the librarian does not make a card for you with the word that you think of, or the words that you think of, because you might check a whole bunch of them, you cannot find that book. It's there. It's in the library. It's relevant to your information need, but they didn't stick a word on it that matched what you thought of, and now you cannot find that book. You don't even know it exists. It's there. It's in the collection of all the books, but it's not retrievable. It's not accessible to you. All right. This phenomena is known as vocabulary mismatch. The vocabulary that the user uses and the vocabulary that we use to represent the book in our information retrieval system, the vocabulary is not the same. They mismatch. If they were to match, I could find them, but they're not. So we've got this big issue of the vocabulary mismatch. Now, this has been studied, in fact. There is great work by Furness et al. Back in 1983. And yes, that's a long time ago, but not really long ago. And so this kind of gets at how recent so much of what we've been studying, what we'll study actually is. A huge amount of all this research has taken place since largely the invention of computers, which in the scale of things is very recent. So this isn't like physics and like so much of what goes on with the basics of engineering. This is very recent stuff, which I guess is like information systems is very recent in that sense as well. But nevertheless, what they found is that if you ask people, you give them something to describe. Maybe, I don't remember exactly what they did, whether it was a book or a picture or something, I don't know. But if you ask for a single word description of it from people, so give me a single word to describe that thing. Only 10 to 20% of people agree on what that word is. That is not good. So largely, we ask people to label an item to do this job of subject indexing, and we ask another person to do it. There's not going to be a huge amount of agreement between them. Sure, Maybe they both pick woodworking for a book, but the other subject words, we're going to get less and less agreement, especially as those words become more and more focused on the particular topics in that item that we're looking at. All right, so how do we fix this? Well, you might say, so how to fix? Well, one possible solution is make more cards, right? Don't just have the librarian make one subject card. You got to have enough subject cards that there's a good chance that the things that I'm looking for, the words that I will come up with as a user, would be able to locate and find that item. And of course, books contain multiple topics in them as well, so we need to kind of describe those as well. But this then runs us into a problem. Okay, so as the number of cards increases, the greater the chance we get a match. And mismatch. Okay, so yeah, so the librarian makes a bunch of subject cards, and maybe the book is only sort of slightly about this thing. It's one of the items, but it's only sort of slightly about it. Oh, yeah. Now, when I go to look up in the thing, I'm flipping through and I get a subject, and the subject is woodworking. And then the title of the book is Accidents in the Workplace. And it's like, oh, maybe there's woodworking accidents in the workplace. But great. So now I've wasted my time. So that's a book that I don't find relevant to my needs. It did match a book, but it's a waste of my time. Then again, of course, the person who was looking for woodworking accidents, maybe they had thought up the word woodworking and they're like, woohoo! But for them, when they look up woodworking, they get all these books about how to build stuff. And they're like, that's not what I'm looking for. I'm looking for accidents in the workplace with woodworking. So as we increase the number of cards, we increase the ability for people to potentially find stuff, but they also have to wade through more stuff that's not relevant to them. So this introduces us to a very fundamental concept in information retrieval known as precision and recall. So precision is the number of relevant items. Remember, relevance is what I consider relevant to me and my needs. Number of relevant items found in my search divided by the total number of items matched. Or we could say returned if we're talking about search results. Us finding cards matching the subject term, that's like results being returned by the system. So precision, it's the fraction of stuff that I had to see. What fraction of it did I actually consider relevant? This information retrieval system, I love 100% precision, a precision of 1, because everything I look at, that was good. I like that. That was good. Now, but that's balanced against this issue of recall, which again is the number of relevant items that I find. And again, relevant is not, oh, it contains the words. No, that's not relevant. Relevant is, that's what I wanted to find, and it's helping me satisfy my information needs. That's what relevant means, okay? So number of relevant items found, and divided by the total number of relevant items in the collection. So out of, let's say, the whole library and items, let's say books, if we could go through all of the books in the library and identify which ones are relevant, that one would be in the denominator here. So finding how well am I able to find all of the things that might be of use to me, and the issue of the things that were matched, what fraction of them actually were things that I cared about. So in general, the general trend is as we increase recall, so if we work to manipulate a retrieval system to increase recall, and again, that's like the librarian adding more and more subject cards for every single book, we typically lower precision. These things are inversely related in information retrieval systems. Our goal is perfect precision and perfect recall. We want everything, we want to find everything relevant, and we don't want to waste our time viewing anything that's not relevant. All right. By the way, think about what happens. It's really easy to get 100% recall. Just return every single item in the system. Now I have to go through them all, and my precision is absolutely horrible. Okay, so that's the extreme, and we don't want that. All right, we're moving on here. This is a long lecture. Imagine you're in class, and it's it's one of these Tuesday, Thursday long lectures that goes on for an hour and 20 minutes. That's what we're dealing with here. All right, so we've got I talked about these alphabetical catalogs. These are primarily found in the United States. These are not the only form of catalog. In Britain, in particular, they also had classified or classification style catalogs, where the cards are stored in a classification scheme. So a classification scheme, animal, plants, types of animals, whatever, it's a hierarchy, so to speak. And we try to figure out what is the classification scheme that we can contain all human knowledge under. And of course, that scheme has to change and evolve over time, but we do that. And when it comes time to make the cards, we label the cards, the subject cards, with things from the classification scheme. And a book can certainly be classified multiple parts in the classification scheme. All right, and so part of the thing is just knowing and being able to use a classification scheme to use this type of system. All right, now, one of the things that would be interesting is that people used to, it's quite amazing, but there is this notion that people used to, these librarians, the inventors of these systems, would basically get together and say, my system is better than your system. My system helps people find books better than your system because, and they would give some argument about, the way people think, or the way we think people should be able to find things, or what makes sense, or this is very sensible the way this works. And it was just, I think this, you think that, I think this, and so you might think that's crazy, and I agree, but that was what was going on. And so Cleverdon, a researcher in Great Britain, or the United Kingdom, Cleverdon said, that's crazy. He agreed. He said, that's crazy. I want to measure. I want to actually measure what is a better cataloging system. What is a better way for us to deal with this? And so he ran a series of experiments known as the Cranfield experiments. These were Cranfield because they were at the Cranfield University. But a big thing is these were experiments. These were ways to actually measure and find out what was working better. And his first set of experiments, called Cranfield 1, The big thing here is that he basically found that the different types of catalogs, so the different types of catalogs all performed about the same. So these people arguing my catalog's better than your catalog, it was bunk. You know, there really wasn't any difference. But what he did find is that the big thing was the issue was choice of the index terms. And this was both from the side of the library or the person who had done the indexing, as well as the user, the person doing the searching. So the user might not come up with the right word. This is when we accuse the user of not doing the right thing. They might not have come up with a word that would have helped them find something. Same thing, the librarian might have labeled things in a way that didn't help the user find things. We might say they've made mistakes, but nevertheless, he found the biggest issue there were these index terms. Now that led him to his next set of experiments, his Cranfield 2 experiments. And all these experiments were a huge amount of work. These was largely manual indexing systems. He wasn't using books. He was using articles, scientific articles. Nevertheless, in his Cranfield 2, so he looked at this way, different ways to represent the items. So how should we pick the words, basically? How should we index them? What's the words that we should use to represent the item in the collection? And this resulted in a really big finding, in that he discovered that picking words, so he was basically like, oh, one of the simplest things we'll try, it's kind of like a baseline by which to measure the more sophisticated approaches. We'll just tell people to pick words like from the titles and abstracts of these documents. You discover that picking words, from titles, abstracts, worked, or let's say, better way to say this is could only be bested or bettered, or let's say bested or improved, I'll say improved on with the addition. So start with those words with the addition of synonyms and basically he called them confounding terms, but these are basically stems. Stems, we'll talk a little about this a little bit more, but this is when we have words like run, running, ran, runner, etc. They all have a stem basically of the word. Could reduce them all to the word run. So we could include the word run along with these other words when we index, and that helps people find things. Anyway, so all right, he discovered this. Now, the other thing that I want to mention about this is, again, he had a systematic way of doing this experimentation. This was not about let's bring people in and have them use the system and tell me whether they like it or not, how satisfied they are. But it came down to, we are going to, some of the experiments were, they asked, this was people who knew the scientific literature that they were looking for, what are the types of things they wanted to look for, and so he would capture that search information need. And so, I'm looking for documents that talk about airfoil shapes of supersonic jets. I don't know. And Okay, we've got that. And he would actually, and these were fairly small collections, and he would have the people go through all the collection and identify all the known relevant items. And then he would turn that information need basically into a search with the different systems and then measure how well they actually found the set of known items in those systems. This experimental methodology, which is largely known as Cranfield style evaluation, is fundamental to information retrieval. It has allowed the incredible performance that you see today. It's through this experimentation that has all happened. And it all started with Cleverton. Now, so let me summarize this. And again, details that can be found in that chapter 9. There's some things that I haven't covered in that chapter 9 yet. We'll cover them in the future. Basically, thus was born the modern age of information retrieval. And what was it that really did it? Got us sort of out of the dark age of arguing about what's better was Cleverton brought experimental science. Okay, where we measure quality of the search system to know what works better. And everything that we'll see in information retrieval always comes back to, well, how do we know whether it works better or not? How do we measure it? We're always super concerned with this, in particular because you could see back from the beginning of the lecture how difficult it is. Oh, different users have different conceptions about what will help them for their information need, even if those people come to us and give us the same basic query, okay? So this is a complex thing. A huge amount of work is there, but it's critical. We can't improve things unless we can measure. We can't know whether something is better than something else unless we can measure whether it's better. Okay, so measurement is an extremely important part of this field. But another thing was the big part was that an item, so we talked about books, but an item's words describe it well. That was a big discovery. That it wasn't so much the human brain looking at it and deciding what words. The item's words already were there that were valuable and important, okay? And this really leads us to, so what we had subject indexing. So librarians picking words, this is manual indexing of items. But this really leads us to the world of automatic indexing, because if it just is a matter of taking the words from the item, well, we can get a computer to do that, all right? We can get a computer to take a document, break it up into words. Now we have all these potential words. Oh, but wait a second. We've got this problem. We have all these words, and now we're going to potentially, if anyone types in something, we're going to get a huge number of matches. So imagine we take up a document and we chop it up into words, and it's got a word like the in it. It's got a word like of and these articles. Well, every English document has those words. If a user uses some of those words or something, we're going to find all these huge number of matches, and our precision of our results is going to go to garbage, to zero, So, and likewise, you might have a huge book and it just mentions the word shark once. It's not about sharks, but it just mentions shark for some reason. You're looking for something about sharks. That's probably not the book that you're going to want returned to you. So, if we do this in an automatic fashion, we have to find some way of figuring out how to use all those words in a sensible fashion. And thus was born the need for coming up with better algorithms for actually automatically looking at a document, deciding how we're going to break it up into words, and how we're going to use those words with regard to users looking for the items in there, such that we can actually find things that users will find relevant, and that will, when we run the experiments, will tell us this works. This algorithm is better than another algorithm. All right. That's the end. Thank you very much.